Professor Belfrost's science class is back.
Hi everyone, dear students, welcome back to my channel. So here I'm Professor Belfrost will again discuss some problems related to examination papers that I have collected so far with you every Saturday. So without further ado, let's get started. Okay, so here I want you to take a screenshot first about the problems that we are going to discuss. As usual, I have prepared three questions, one for physics, one mathematics, and one chemistry. Okay, so pause the video first and give it a try. After you have found the answer, then go back and check if your answer is correct. If you have something that maybe you want to ask, just drop a comment below, okay? Okay, so we start from the first question. So the what? The key point of this question is the diagram that given. A cyclic diagram, a cyclic Vt diagram that's given of one mole monoatomic ideal gas. Okay, so let's see option A. Process 1 is an isochoric process. How we know a process is isochoric or not? Okay, isochoric means the volume is constant, but here we see the volume is changing. The volume decrease, so it mustn't be an isochoric process. So A is incorrect. Very easy. Then option B, we have in process 2 gas absorbs heat. Okay, so in process 2 Q equals delta U plus W, and delta U, the change of internal energy, equals 0 as the temperature is constant. Therefore, we only have Q equals W. Here, W, the work done, equals P, the pressure, times the final volume minus the initial volume. And because the difference of the volume is positive, then the W is positive. The work is positive, meaning the gas absorbs heat. So B is correct too. How about the process number 4? Actually, the process number 4 is just the reverse, the opposite of the process number 2. So we know that number 2 process is correct, then number 4 statement must be correct. It's just the opposite. When one absorbs, the other release. So C is also correct. Now we have the option D. Processes 1 and 3 are not isobaric. How we know a gas undergoes isobaric process? For an isobaric process, yeah, it means that the pressure is constant along the process. Then, because P is constant, then V must be proportional to T, meaning we have a straight inclined line in TV diagram, not the TV paragraph. I'm sorry, I mistyped. Certainly, 1 and 3, I'm sorry, I mistyped again. 1 and 3 is not isobaric process. So D is incorrect. So B is correct, I'm sorry. So the correct answers are B, C, and D. Okay, now we will solve number 2 problem. Yeah, we have a quite complex equation to be solved, but actually we can just disseminate it into parts. So I've disseminated for you, you see. So the one the one expression before the time is A, and the other expression following the multiply symbol will be B. So we start from A. For A part, we pay attention first to the form log base 2 of 9, because this expression keeps occurring. You see, the internal one also have log base 2 9. Okay, we can change this actually to log base 2 3 to the power of 2, and we can just move the 2 to the front of the log. So we have 2 times log base 2 of 3. Then we may substitute this to the A form, the initial A form, and we obtain a form like this. I will not read it because you can see it by yourself in the slide. And tada! We have the last uh, expression. You see, 2 times log base 2 3 to the power of log base 2 times log base 2 of 3 of 2 times 2. Because if we pay attention, we have the form of a log base a of b, then actually this form can be reduced to just b. So now we have reduced the form to b, where here b is 2 to the power of 2. So we have 4. So we have find out we have solved the a equation, the a expression, and it is 4. Now let's solve b. Okay, so we change a little. Okay, so square root of 7 become 7 to the half, to 1 half, and we also have a power again, power log base 7 4, and then it changed the expression to like this: 7 to the power of 1 half times log base 7 4. Because we can actually move this half to the 4 to be the power of 4, then we have this 7 to the power of log base 7 4 to the power of a half. So because I have told you before that this form can actually be reduced, then we have this 7 to the power of log base 7 of 2. Then we only have 2 eventually. Then we have solved A and we have also solved B. Now we just need to multiply them as what the question expects us to do. So 4 times 2, then we get 8. So we have solved number 2 problem. Number 3. So here we are about to solve a problem related to Gibbs free energy for a reaction at non-standard state condition. Let me read the question for you. So we have following cell. I will not read it. You can just see the screenshot where the concentration of G into positive is 10 times the concentration of copper to positive. The expression for delta G, yeah, in joule per mole is where F is Faraday constant, R is gas constant, T is temperature, and E0 cell equals 1.1 volt. So how to solve this? Yeah, I'm very sorry, but I have to tell you that you need to memorize some equation, some formula, I mean, before you can solve this problem. What equation or what formula we need to memorize? Here we need to memorize Nernst equation, written as this: E equals is 0 minus RT over NF times ln Q, where R is 8.3145 joules per mole Kelvin, and is number of mole. We can find it later when we have the chemical reaction with us. F is periodic constant. Okay, so it is 86,485.309 coulombs per mole. Q is the reaction quotient. Again, the reaction quotient can be obtained only if we know the chemical reaction. In the problem, we have been given the information that the E0 of the cell is 1.14. So that's enough. And from the given cell, we can write down this reaction. Zinc solid plus cupron 2 positive aqueous is reacted and becoming zinc 2 positive aqueous and cuprum. Then we know from this reaction that the number of mole of the electrons equals 2. And we also know the quotient is basically just the concentration of the zinc over the cuprum. And it has been given in the problem that it equals 10. Thus, we can write the equation as E equals 1.1 minus RT over 2F times ln 10. And we also know, actually not know, but we have to memorize this equation. Delta G, the Gibbs free energy, equals minus NFE. E is the energy that the Nernst equation that we have solved before. So we can written it as del G equals minus 2F 1 times 1.1 minus RT over 2F times ln 10. So delta G equals minus 2.2F plus RT times 2.303. And tada, we find the answer. So delta G equals 2.303 RT minus 2.2F. So the correct answer of number 3 is B. I'm sorry, my English is not very good, but I think you can read it in the slide by yourself. Okay, so that's for today. And here I have another good words for you today. So W.B. Yeats once said, the world is full of magic things, patiently waiting for our sense to grow sharper. Yeah, it's the same as when you learn something. At first, you know nothing, barely nothing. But as you learn, as you dig deeper, and you will enjoy it more and more because it's just an adventure map, and your sense will grow sharper when you do more exercise. That you help yourself to grow better to understand the topics and the concepts. So I hope you always enjoy science in any ways that you like. Okay. So uh, being said, that's for today. Thanks for watching. So here's what you have to do after watching this video. Subscribe to this channel if you haven't. Give a like to each video, comment about your thought, and give feedback to me. And share this video to your friends. Okay. So my class will be on every Thursday, not Tuesday, Thursday, and Saturday. So keep watching and be thoughtful. Goodbye. See you.